In our first video, we'll look at section 1.1 on set concepts. So this first section is a little bit heavy on the vocab, a little bit more so than your traditional math courses will be, but that's the idea behind this course, is that we do look at some traditional math ideas in sort of a new context, a different way to see them. So first, we'll talk about what we mean by set. So a set is just any collection of objects. Could be numbers, could be people, computers, letters, desks, pencils, any type of objects. Obviously, this being a math class, we'll be spending a little bit more time with number sets than other types of sets. But that is just one key thing, is that a set can be any collection of objects. So these objects that make up the set are called either elements, that's the more common one. You'll sometimes hear it referred to as members as well. So I could have a set of 3 pens. This black pen is an element of the set of pens on your screen right now. So some ways to describe a set. We could use a sentence. We could use what's called roster notation. And we could use what's called set builder notation. And we'll go through each one. So the sentence one, you know what a sentence is, so we won't spend tons of time on that one. And roster and set builder are more useful to us in math. So sentence, set of pens on this page. So that would be an example of describing a set, just a verbal description or a written description. So roster notation . If you're someone that watches sports, you might hear them refer to a team's roster. That's just a list of people playing for whatever team that is. In classrooms, we have a class roster, a list of everyone involved in being a student in that class. So it's just, think of it as a list. We give the name with usually a capital letter. So if set A is, let's say, the set of Hindu Arabic digits. I'll give you the sentence version first, and then we'll look at its roster version. So roster says just list that out, just show them. So we have a brace at the front and a brace at the end, capital letter to give you the name of the set. So Hindu Arabic digits, those are the ones that you've used all your life. Just likely no one told you that that was the name of what you were working with. So set A, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. On larger sets, we can sort of follow a pattern and let the reader know that we are just going to continue following that pattern by showing maybe the first 4 elements, maybe 4 to 5 elements, and then an ellipsis says this pattern continues until, and then 1 more comma, we reach whatever the final element is. So that symbol is an ellipsis. Just saying this pattern will continue. So that would be the roster form for Hindu Arabic notation. Then we can take a look at some other special types of sets. Set B is set of all 2-year-olds with a valid Illinois driver's license. So hopefully there are no licensed to drive 2-year-olds in the state of Illinois. So if I were to do this in roster notation, I would give it the letter for the name, the equal sign, the brace, but I wouldn't have anything to put in it. So if I don't have anything to put in it, I just close it on up. There is one other commonly used symbol for this. I tend to typically use this version of, this is referred to as the empty set. You'll also see it written as a circle with a slash through it. So as a heads up, if you are one of the people that writes, for example, the number 20 with this symbol in it, break that habit now. That means something totally different. This is not a 0. This is a 0. This is an empty set. Not the same thing. So again, not every semester, but every couple semesters I do have a student that will use the empty set symbol for a 0. They are not the same thing, not interchangeable symbols. You also can't use a 0 here as well. Empty set or empty set symbol. Again, this being my preferred one. This is the one I use more often. Okay, some more notation before we get into set builder. If set R contains elements, let's say 5, 7, and 9, and set T contains elements 6, 7, and 8, if I want to tell the reader that, say, 5 is an element of set R, here is our symbol for is an element of. So it looks like sort of a cross between a C and a capital E. Is an element. So 5 is an element of set R. I can also say that 5 is not an element of set T. Very similar symbol, and just like a no smoking sign, we just put a slash through it. So 5 is not an element of set T. All right, a little bit of work on now our friend the set builder notation. So the idea behind the set builder notation is we're just giving the reader directions. Think of it like the IKEA furniture of the set world. You're giving them directions on how to put it together. So the basic format, A is the set of all blanks such that, and then some description. So what that would look like in symbols. So we're still using capital letters to indicate that we're working with a set and just giving it a name, A, B, C, D, etc. So the set of all, and then we have something in there, set of all X, set of all P, set of all P over Q, other things. And we have this straight line that is the such that, and then our description. What does it take to be part of this set? So for example, if set B is the set of stats courses at SSC, and B is the set of all X such that X is MTH 126 or X is MTH 211. So we have two different stats courses offered. So this is just saying here's how to build the set. I can say, okay, C is a set of counting numbers between, let's say, 5 and 600. So counting numbers, what we mean by that, basically no fractions, decimals, negative numbers. So just like the counting numbers you started with in kindergarten. We'll give that a more formal mathematical name for that set later. For now, we'll just say counting numbers. So 1, 2, 3, 4, 5, 6, etc., etc. So if we want that in set builder notation, C is the set of all X such that X is a counting number and 5 is less than or equal to X, which is, I could say less than or equal to 600. I could say strictly less than 601. A couple different ways to say the same thing. So again, I just chose to show you I can change up a little bit how I write it. This still covers the same numbers. Here, if I didn't want to have the or equals part of my inequality, I could have dropped that guy down to a 4 and said 4 is less than x, which is less than 601. Really, any combination of the strict inequality or just the less than or equal to symbols would still work, depending on how I adjust these endpoints. So in fact, I encourage you to just quickly pause it and see if you can find the 3 other ways that I could have written set C in set builder notation. So just go ahead and pause the video, see if you can find the other 3, and unpause it when you're done. Okay, welcome back. So hopefully all of yours started the same as the example here. So C is a set of all x, straight line that's read such that x is a counting number. And so maybe I had the or equals on both of them. And then a brace to end it. You do need the braces on them as well. Braces are required both for roster and set builder. So set of all x such that x is a counting number. And we could have done the 4. 4 is less than x, less than 601. I believe I actually described that one when I was talking about the other forms. And our last one, set of all x such that x is a counting number. And let's see, we have 4 is less than x, which is less than or equal to 600 would be. So any of these 4 would be a set builder notation of set C. I just wanted you to get a little bit of practice in trying to show that. Okay, so next up, the cardinality of a set. We'll just name our set A for now. It's just counting how many elements you have. So for example, if our set A is the element 50, then cardinality of set A is 1. I had 1 element in set A. I'll use M. If set M contains A, N, V, and T, then the cardinality of set M, denoted N of cap M, would be 4. So notice here, capitalization is important on this. This is a capital letter for the name. This N is lowercase when you're denoting cardinality. Now, one useful number set that we'll look at early on is a set of whole numbers. Basically, if you slap a 0 in front of the counting numbers, you have the whole numbers. So the notation, cap W, you might actually see it bolded or with an extra line in it. But that is, as I mentioned, we just include the 0. 0 is a useful element to have. 0, 1, 2, 3, 4. And really there is no biggest number. If you think you found the biggest whole number, add 1 to it. And if you think the result of that is the biggest whole number, add 1 to that again. And we could just keep playing that game forever. I could keep telling you to add another 1 on. So instead of another comma and another number after that, we just have the ellipsis saying this thing just keeps going. If the set keeps going forever, this is what's referred to as being an infinite set. So I can't tell you the cardinality of this set. It just goes on forever. I can't give you just one number or one whole number to represent the cardinality of that set. I can't say it has 50 elements. I can't say it has 1 billion elements. I can't say it has 1 trillion elements. It's an infinite set. It goes on forever. Anything that we can give a number for, such as set A and set M here, these are finite sets. You can give a nice, pretty whole number solution to the cardinality. All right, another important idea in sets, the idea of equal and the idea of equivalent. We'll start with equivalent. So set A and set B are equivalent if their cardinalities are equal to one another. So here, let's do set F. Contain elements A, B, C, and D. Set G. Contain elements G, H, I, and J. And again, here's another good reason why you want to really watch your capitalization. Don't just use all caps or all lowercase when you're working with sets. That does make a difference. Cardinality of set F would be 4. We have 4 elements. Cardinality of set G, 1, 2, 3, 4 elements as well. So set F is equivalent to set G. For the sets to be equal, they have to have the same elements. So A is an element of set F. A is not an element of set G. Therefore, these sets are not equal. So they are equivalent, they are not equal. So if you could basically do a pairing, replace the A and G, just pair them up, pair the H and the B, pair the I and the C, or pair the D and the J, then they are equivalent, but they are not equal. But if I create set, let's say cap H, and that will be D, B, A, C. Sets F and H are equivalent since they do have the same cardinality. They also have exactly the same elements. A is in both, B is in both, C is in both, D is in both. They are also equal to one another. So they're both equivalent and equal. So equal is sort of the stronger of the two conditions. All right. So let me have, I need a little bit more room. We'll flip to the next page and then I'll have you try one. All right, so set A contain dog, duck, cat, bird. Set B will contain 95, 96, 97, 98. Set C will contain 30 and 207. And set D will contain 96, 95, 98, and 97. So see if you can find all the pairs of equivalent sets, and then see if you can find all pairs of equal sets. So go ahead and pause the video, see if you can find those combinations, and unpause when you're done. Okay, welcome back. So our pairs of equivalent sets, cardinality of set A was 4, cardinality of set B was 4, cardinality of set C was 2, and cardinality of set D was 4. So everybody with a 4 is equivalent. So A and B are equivalent. A and D are equivalent. B and D are equivalent. Let's see, we'll just use parentheses to kind of group them together. Pairs of equal sets. We only have 2 of them that have exactly the same elements. 95 in both B and D, 96 in both B and D, 97 in B and D, 98 is an element of both B and D. So B and D are equal. So that's our only pair of equal sets. And then our last topic in section 1.1 that we need to go over is the idea of the universal set. So universal set of all elements relevant to a given problem. So this is a huge topic in stats for those of you that are going on to Math 126. Universal set is a big concept in the stats world. So let's say that I'm studying something about Mth097. I could decide that my universal set will be all of you, students in my one section this semester of Mth097. My universal set could be the set of all Mth097 students taking courses this semester, or my universal set if I'm doing sort of a bigger study. Maybe it's all students that have ever taken Mth097 at South Suburban College. So it can vary from problem to problem what the universal set is, but the idea is just kind of what elements are relevant to us in the problem that's in front of us. So I'm going to ask that you try out the 1.1 homework problems that are in your book. Mr. Anderson arranged the text a little bit different than some other math textbooks. All of his practice problems are at the end of the chapter, not the end of each section. So you'll need to flip all the way to the end of chapter 1 to see the 1.1 problems, and then we'll start next class with any questions that anyone has from section 1.1. If you have any questions, please feel free to get a hold of me. Stay safe, and I will see you next time.